Hello friends, welcome you all in this session. In previous session we discussed payback period method and ARR. These two are non-discounting capital budgeting techniques. We will continue with ARR. So average rate of return, also known as accounting rate of return. There are large number of measures of ARR. Why? Because ARR is ratio of, in layman's term I can say it's the ratio of income to investment. Since you can measure income in several ways and investment in several ways, that's why you have got large number of ways of calculating ARR. We will see couple of those methods, right. So the first is this, average income after tax divided by initial investment. You can have average income after tax divided by average investment, right. So here it is initial investment, here it is average investment. So you are measuring investment in two different ways, right. The third one is average income after tax but before interest divided by initial investment, right. Similarly you can have average income after tax but before interest divided by average investment. The fifth measure is average income before interest and taxes, right, and this one was after tax but before interest, while in case of E it is average income before interest and taxes divided by initial investment. Here it was average investment, right. The next measure is average income before interest and taxes divided by average investment. You have got this measure also, total income after tax but before depreciation minus initial investment divided by initial investment by 2 into number of years, right. So these are, you can say, 7 measures, right. Let us look at an example and calculate all these measures, right. So this is the question. So there is a project, the initial investment is 1. So you have got depreciation year wise, it's 0.2 every year. It's income before interest and taxes. So first year is 0.3, next year 0.35, fifth year 0.35, right. Interest is same in all these years 1 to 5. So this is the total interest. Income before tax, how would you calculate this? So this column minus this column is income before tax, right. What is tax? Tax is 0.10 in first year, 0.125 in fifth year, and this is the sum of all these taxes, right. Income after tax, this is 0.10, 0.125, this and other values are also given here, right. So you have been given income after tax, this is the sum and this is the average, right. So average value for all these columns are also given, right. So average investment is 0.6, average depreciation is 0.2, income before interest and tax 0.36, interest 0.10, income before tax, this tax and income after tax, right. So if I ask you to calculate this measure, average income after tax divided by initial investment, what that value would be? Can you calculate? Average income after tax divided by initial investment, and this is your question. So initial investment is what? 1, right, and what is this? Average income after tax. Average income after tax, where it is? Where is average income after tax? It's 0.13, right. So average income after tax is 0.13 divided by initial investment, this is 1, right. Let us look at second measure, average income after tax 0.13 divided by average investment. So in first formula it was initial investment, now it is average investment, which is 0.6, right. Similarly you can calculate other measures. So all these are nothing but ARR, different ways of calculating average rate of returns, right? And why there are so many? Because you are measuring income and investment differently, right? Let us look at couple of demerits of this method. Though this method is better than payback period method, but there are a couple of drawbacks, right? This method ignores time value of money, just similar to payback period method. This method takes into account accounting profit rather than cash inflows, and hence ignores the fact that actual cash flows can be reinvested. So this is the drawback, right? ARR can be arbitrarily fixed. For example, ARR is 10% good for me, but may not be good for you, right? So managers can arbitrarily set ARR, which is also a drawback. And as I said, the concept of average investment and average earnings differ widely. So you will have different results, right? So this is again one of the drawbacks. Let us look at now some discounting techniques. So far we have seen non-discounting techniques, right? Namely payback period and ARR. Let us look at discounting techniques, right? And the first one is discounted payback period method, right? Discounted payback period method. Then you have got profitability index, you have got NPV, you have got internal rate of return, right? So we will see discounted payback period method, but before this let us look at once again the concept of time value of money, right? So we are saying that money available today is more than money available tomorrow, right? So we will define some terms over here, right? So there is something called present value. What is present value? Any value which occurs at the beginning of the project is known as present value, and generally we take 0 as a baseline. So we convert all cash flows in their present value for analysis purposes, right? Let us once again define present value factor. What is present value factor? You can easily calculate from here, right? Present value factor is nothing but present value divided by future value, right? So it's the ratio of future value, it's the ratio of present value and future value, and this present value factor is available in the form of table in any of the books on project management or accounting management, right? So we defined present value, right? Now let us define what is future value. Future value is the last cash flow is generally called future value. So it can be understood as the cash transaction taking place after certain duration of time. If the same amount is transacted after a regular interval, then it is termed as annuity, right? So what is annuity payment? So if you go by literary meaning, the yearly payment that occurs every year for more than 1 year, that is annuity payment. But it's not necessary that may occur on yearly basis. You may have quarterly basis or monthly basis or weekly basis also, right? But the duration between two successive payments remains constant, right? So that is annuity payment, right? As I said, each payment if taken alone is future value, otherwise it is annuity, right? There is something called discount factor. Discount factor is the expected returns per unit of period over the life of the project, right? So it is necessary to understand that if annuity is for quarterly payment, the annual expected return should be reduced to 1 quarter for computational purposes. If annuity is for, let us say, monthly payment, then it is to be adjusted accordingly. So, the return should be reduced to 1/12 if it is monthly, right. Number of periods, of course, what is the total number of periods which are there in the project is number of periods. It should again be noted that if transactions are done yearly, it is the number of years, but in the situation of quarterly payment, the number of periods should be quadrupled the number of years. So, this is important point you should keep in mind, right. Okay, let us look at this question, very simple question. Mr. Sharma wishes to invest some money for future need of 5 lakh after 5 years, right, at the rate of 9%. How much money should he deposit in bank? So, the first question is, if let us say if I want 5 lakh rupees after 5 years and the interest rate is 9%, so how much should I deposit today? This is the first part of the question, and second part is, if interest is paid semi-annually, then how much money should be deposited in bank? So, there are two parts in this question, right. So, how to solve this question? Just try this. Okay, let me solve this question. It's a simple one, right. So, present value is 5 lakh, right, divided by 1 plus this is your 9% value, right, it's 0.09 to the power n, right, n is number of years, right. So, this is 5. So, this value is 3,25,000. So, if I want 5 lakh rupees after 5 years, then I will have to deposit 3,25,000 in the bank at the rate of 9%, right. The second part of the question is, what if interest is paid semi-annually, right. So, you need to multiply n by 2 and r is to be divided by 2, right. So, this 5 lakh divided by 1 plus is 0.045 to the power 10. So, this is 3,18,712 rupees, a very simple question, right. Let us try this question. Let us say Mr. X wants to receive 120,000 every year for next 10 years. How much should he deposit now if interest rate is 10%? Question is, Mr. X wants to receive 120,000 every year for next 10 years starting from next year from now, right. How much should he deposit if interest rate is 10%? Okay, let me solve this question. So, you have got this present value of annuity of 1 rupee for period T. So, this table you can find in all the books related to project management, in most of the books, not in all the books, and the books of let us say financial accounting and so on. So, what is the solution? It's for 10 years and interest rate is 10 years. So, you just see period is 10 years, right, this, and interest rate is 10, right. So, this is 6.145, right. So, just multiply 120,000 by 6.14. So, you will get this value, right, it is 7,37,400, right. So, this is the answer to this question. Let us now move on to the first discounted capital budgeting technique, which is discounted payback period. So, it is similar to what we have seen in non-discount capital budgeting technique, but here we discount the payback period, right. we discount the cash which we are receiving by a discounting factor, right. So, while evaluating projects with this particular method, present value of cash flow are considered instead of cash flow itself, right. This is the important point, right. So, let us say if I am receiving 10,000 rupees next year, so what would be the present value of that 10,000 rupees? So, that is what we do in this particular method. So, discounted payback period method is the length of time required to recover the initial cash outflow from the discounted future cash flow, right. Formula is similar to what we have seen. So, this is Y0 is the year just before the payback period is attained. Cumulative present value of Y0, this is CU PV0, right. So, this is cumulative present value of Y0. CF1 is cash flow of payback year, right. So, let us look at this question. So, find out discounted payback period if discount factor is 10%. How would you solve this question? Cash flow is minus 140, 30, 40, 50, 60 and 45, right. Now, what we should do? We should find out discounted cash flow, right. You can do two things, right. Either you can calculate first cumulative cash flow and then go for discounting, or first you go for discounting and then calculate cumulative cash flow, right. So, in this method, let us first will calculate present value factor, right. So, this is PVF, which is 10%, right. So, this is, so initially this is your cash outflow minus 140, your present value factor is 1, right. So, present value is, just multiply these two, is minus 140 multiplied by 1, this is minus 140, right. Okay. Now, this present value factor is 10%, right. So, this 1 divided by 1 plus 0.01, right, and this is equal to 0.90, right. So, let me draw a table like this. So, this is 0.9. Now, what is present value of 30 rupees? It is 30 into 0.90, which is equal to 27, right. So, this is present value factor, which is 10% in this case. This is present value, right. So, you need to convert all these cash flows into their present values, right. For this, what it would be is 1 divided by 1 plus 0.01 square, this becomes 0.82, right, and 40 into 0.82, this becomes, it's 33.04, right. Similarly, for third year, fourth year and fifth year. So, you can do it for third and fourth year, let me do it for fifth year. So, 1 divided by 1 plus 0.01 to the power 5, which is equal to 0.62, right, it's 0.62. 0.62. So, how would we get PV? This 45 into 0.62, this is equal to 27.94, right. So, this is the present value of 0th year, first year, second year, third and fourth, of course you can calculate. So, these values are nothing but 37.55 and 45 and 40.98, right. Now since you have got present values, you can easily calculate cumulative present value, right. So this is minus 140 plus 27, so minus 113, right, plus 33.04, so you will get minus 79.96, right, plus 37.55, so you will get minus 42.41, plus 40.95, so you will get minus 1.43, and finally this plus this, so you will get some 26.51, right. So what is discounted payback period here? What you have to do? So this is the by your value from negative to positive, right, in these 2 years. So discounted payback period would be between 4th and 5th year, right. So how it would be? So this is y0 value, right. So y0 is 4, right. 4 minus 1.43 divided by its 27.94, right. It's 27.94, this value, right, and the answer is 4.05 years. Very simple method. Only the difference between payback period and this method is you need to calculate this present value by using discount factor, right. So I hope you can solve similar questions. Let's try this question. Now the discounting factor here is 10% and cash flows are like this. So can you solve this question? I hope you can easily solve this question. So let us look at this solution. So present value factor is 1 here. So minus 300 into 1 minus 300, and cumulative present value is minus 300, right. Since discounting factor is 10, all these values are remain as it is, right, what we have seen in previous case, right. So 0.90, then 0.82, right, then 0.75, just check these values, right, 0.90, 0.82, then for 5th it is 0.621, right, and similarly if you want for 3rd and 4th year it is 0.75, and for 4th year it is 0.68, right. So these values are same as it was there in previous example, right, because discounting factor is 10, right. So how to find out discounted payback period here? Discounted payback period is 3 minus, right. So here it is moving from negative to positive, right. So 3 minus 26.02 divided by 122.94, right. So discounted payback period is 3.21 years, right. Now let us look at couple of other capital budgeting techniques. There is the first one, another one is profitability index. So profitability index is ratio of cash inflows to cash outflows, right. So this ratio, if it is 1 or more than 1, then you should go for that particular project. We'll say that project is a good project, right. So you can calculate PIS, sum of all cash inflows divided by cash outflows, right. Don't interchange these values, right. So in denominator you have got outflows and inflows is numerator, right. So inflows have to be more than outflows, right, then only you will say project is profitable, right. So and the net profitability index is profitability index minus 1, right. So this is profitability index. Now let us look at next method. It's NPV, net present value. It's one of the most widely used methods, right. So, it is very simple to use and evaluate on the basis of wealth maximization objective. So, what is net present value? So, it is the difference between present value of cash inflows and present value of cash outflows. PI was what? It was the ratio of cash inflows to cash outflows. Here it is difference of present value of cash inflows and present value of cash outflows. So, that is the major difference between PI and NPV. Okay. Let us look at couple of advantages of net present value over earlier methods, right. So, the first is it considers all cash flows, even those cash flows which we receive after attaining payback period, right. So, it considers all cash flows, time value of money, which is again an important point. It was a drawback in earlier methods like payback period and average rate of return, right. Computes contributions towards wealth creation, allows expected change in cost of capital, but there are certain limitations also, and the limitations are requires predetermination of discounting factor. So, a priori you should know what is your discounting factor, and the second limitation is does not consider risk factors, while in a project you need to consider risk as also, right. So, let us try to solve this question. Find out profitability index and net present value assuming discounting factor as 10%, and you need to also tell me, should we accept this project? Is it a good project on the basis of these two criteria, NPV and PI? So, let us solve this question. So, first of all, you have got discounting factor as 10%. So, cash flow is 160 in the 0th year, right. So, this is 160 minus 160 into 1, right, then 30 into 0.9. So, again these values are same, right. So, present value factors are 1, 0.9, 0.82, 0.75, 0.68 and 0.621, right. So, 30 into 0.9091 is 27, right. So, just calculate present value for all these years, right, 1 to 5, and of course this 0th year, right. So, this is your cash outflow and all these are your cash inflows, right. Okay. And these are nothing but present value of future cash which you would be receiving. So, the sum of all these positive cash flows is 200.56, right. So, what is this total? Total present value is this value minus 160, or you just add all these values, you will get 40.56, right. So, what is present value? What is NPV of this question? NPV of this particular project is what? It is 40.56. Why? What is NPV? It is the difference between cash inflows and cash outflow, right. So, this is 200.56 minus 160, right. What is profitability index in this project? What is the definition of profitability index? What is the formula? It is the sum of all cash inflows divided by cash outflow, right. So, inflows is this one, right, 200.56 divided by 160. So, this is 1.25. So, profitability index is 1.25, which is more than 1. So, we should accept this project, right. So, with this let me complete this session. In next session we will see some other capital budgeting techniques. Thank you very much.